This is my geometry course. Today we're going to cover paragraph proofs and flowchart proofs. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. Now, in previous classes in this course, we learned how to do two-column proofs. And we didn't do paragraph or flowchart proofs because I didn't want to complicate things. Two-column proofs are the most common ways to form a proof. But paragraph and flowchart proofs are part of the geometry curriculum, so we're going to review some of the proofs that we learned, but we're going to write them in paragraph form or flowchart form. So we're going to kill two birds with one stone, so to speak, here, by reviewing the proofs and also by learning two other ways to form proofs. So first we're going to learn paragraph proofs, and as you can see, a paragraph proof is just a proof written in paragraph form. So here's a two-column proof. That's what we've already done in this class, a two-column proof. You have your two columns there, statement and reason, but now we're going to take that proof and we're going to convert it to paragraph form. So as you can see, it's just written as you would write an essay or something. So we're trying to show that this angle plus this angle is equal to 120. And so we start with the given information. This angle is 55 and this angle is 65. That's the given information. So I'm going to go ahead and highlight that. And then we go to the segment, the angle addition postulate. So that says that this angle plus this angle must be equal to the entire angle ABC. And then we go to substitution property. So we know that each of those angles, we know the measure of each of those angles. So we can just plug that in here. Plug in 55 and 65, and then we just simplify to get 120 degrees. And so we're going to convert that. And again, that's what we're trying to prove, that the measure of angle ABC, the whole angle, is 120 degrees. So again, that's a basic proof. You may have forgotten the angle addition postulate, but hopefully you see that now. So let's convert that. We have, we're going to start off just by saying it is given that the measure of angle ABD is 55 and the measure of angle DBC is 65. And then by the angle addition postulate, measure of ABC is equal to measure of ABD plus measure of DBC. And also, by the substitution property of equality, the measure of ABC is equal to 55 plus 65. And this equation simplifies to the measure of ABC is equal to 120. So, again, it's just written form. You would write it as if you're speaking, using complete sentences. So, as you can see, this is pretty easy. It's not really a big deal. Now, number two is pretty much the exact same type of proof, except now we're using segments. And again, this is helping you to review the different postulates and theorems and whatnot that we use with proofs. Now, notice that I've already written the two-column form of this proof. All right, so you don't actually have to figure it out. All you have to do is convert this to paragraph form. That's what we're doing in all these problems. It says here, convert the following proofs from two-column form to paragraph form. So all you have to do is just put this into words. So go ahead and do that, and when you come back, we'll work through it together. All right, we're back. So your proof should look something like this. It doesn't have to be exactly the same. Your grammar may be slightly different, and the order of the order of the sentences is probably going to be roughly the same. You may not have the same number of conjunctions, you may not have the same number of periods, or so on and so forth, but it should be roughly the same. So I'm going to zoom in on that if you want to get a better look at that. And pause the video if you need to and just check your answer. And when you're done, we'll go on to the next problem. All right, we're back. So now we're going to try another one of those. So if M is the midpoint of the segment below and AM equals 4, then AB equals 8. So we know that this is 4, and we know that this is the midpoint. So we want to prove that the whole length is 8. So we start with the given information. M is the midpoint of AB, and by definition that means that AM is equal to MB. And we know that AM is 4. That was actually given information. And by the transitive property of equality, we know that MB must be equal to 4. And then we have to use the segment addition postulate as we did in the previous problem, and so on and so forth. So I don't really have to color code these, I guess. It's not really necessary, but if you convert that to paragraph form, it says down here, it is given that M is the midpoint of segment AB, and by the definition of the midpoint, AM equals MB, it is also given that AM equals 4, and so by the transitive property of equality, MB equals 4. By the segment addition property, AB equals AM plus MB, and therefore by the substitution property of equality, AB equals 4 plus 4, and this equation simplifies to AB equals 8. Now this is not an English class. I probably could have written that slightly better, but it's really not that important. The idea is that you can convert a 2-column proof to paragraph form. So again, I have a similar proof. Now we're using angles though, almost the exact same proof in 2-column form, and you don't really have to do it. All you have to do is just convert to paragraph form. So why don't you go ahead and try number 4, convert that 2-column proof to paragraph form, and when you come back, we'll do it together. All right, we're back. So you can analyze the answer there. Just take a while to check that and make sure that it's your proof is similar. And pause the video. And again, the grammar doesn't have to be exactly the same. You don't have to use the same number of conjunctions. You don't have to structure the sentence the same way. It should be the same basic flow of thoughts, and you need to have complete sentences. And your paragraph proof should be okay. But just be aware that your writing needs to be legible, and don't just scribble on the paper. Your writing needs to be proper writing. It needs to follow all the rules of grammar that we use in English. Go ahead and pause the video and look at that answer, and when you come back, we'll go on to the next problem. All right, we're back. So on to number 5. Number 5, it says if angle A and angle B are both straight angles, then they are congruent. So it is given that angle A and angle B are both straight angles. So the measure of angle A equals 180 degrees, and the measure of angle B equals 180 degrees by the definition of straight angles. If they're both straight angles, then the measures both have to be 180 degrees. That's just the definition of straight angles. Consequently, measure of angle A equals measure of angle B by the transitive property of equality. If they're both equal to 180, then they obviously have to be equal to each other. And therefore, the angle A is congruent to angle B by the definition of congruent angles. So if the measures are equal, then obviously the angles themselves must be congruent by the definition of congruent angles. So that's just one example. So for number 6, I want you to write a paragraph proof. Now I'm not actually giving you the 2-column form in these problems. It just says write paragraph proofs for the following statements. So you're going to have to think about this one on your own, but the good news is this proof here that I just did is almost exactly the same type of proof. So we're starting really easy here. So go ahead and try number 6. Put this in paragraph form, prove it, figure out how to prove it, then put it in paragraph form, and when you come back, we'll do it together. All right, we're back. So this should be roughly what you should have there. It is given that angle A and angle B are both right angles. And so by the definition of right angles, the measure of angle A is equal to 90 degrees and the measure of B is equal to 90 degrees. by the transitive property of equality, measure of angle A equals measure of angle B, and by the definition of congruent angles, angle A is congruent to angle B. So you can pause the video and look at that if you need to. And when you're done, we'll go on to the next problem. All right, now we're going to do flowchart proofs. Again, paragraph proofs are pretty easy. There's not really much to it. So a flowchart proof is a proof that uses arrows in blue. Here's an example. It uses arrows to show flow of thoughts, bubbles in green to show statements, and spaces in purple under the bubbles to show reasons for the statements. Now, you're not going to use colors. You don't really have to use colors. I just color matched these things so you can see exactly what the definition is talking about. So let's go ahead and try or give an example of a proof. So it says here, convert the following proofs from two-column form to flowchart form. So over here we have two-column form, and we're going to convert that to flowchart form. So first, let's talk about this proof. This is just a basic proof that we've already done in this course. We're told that these two segments up here are congruent, and if they are congruent, it's telling us to prove that x equals 4. So we start out with the given information. AB is congruent to CD, and therefore AB, the lengths must be equal, just by the definition of congruent segments. And we're also told in the diagram, or we see in the diagram, that AB is equal to the expression 2x plus 3, and the length of CD is equal to the expression 5x minus 9. And we use this equation here. We just plug those in to this equation here, and we get 2x plus 3 is equal to 5x minus 9. But you see, the problem with these two-column proofs is that it's hard to see the flow of thoughts, because you're starting from here and going to here, and you're also using this information and going to here. But how do you show that? You can't really show it in chronological order very easily. So that's what the flowchart proofs are used for. So we have the given information here, and it follows from that the lengths, because the segments are congruent, the lengths of the segments must be equal. That follows from the congruent statement. And because it follows from that, we use an arrow coming from that. And once we get to this point, obviously you can see we just do the algebra and we get x equals 4. But let's look over at the flowchart more here. So again, this flows from this, or it follows from that. That's why you have an arrow. Now, if AB is equal to CD, and if this information, and by the way, you see how this information is not following from anything. This information is not following from this bubble, because these two pieces of information, they're related, but this doesn't really follow from this. So they're not. You have a separate branch, so to speak, or a separate starting point. But we are going to use this information and this information to go to here. So that's why these two arrows, this arrow and this arrow, are both going to this bubble here, because this information follows from not only this bubble but also this bubble. So that's how these flow charts work. Now, I know what you're thinking. You might be thinking, wait a second, this seems kind of complicated. How am I going to know how to do this? Well, first of all, every flow chart is different depending on the person who's writing it. So your flow chart doesn't have to be exactly the same as mine. It just has to make sense when it comes to the flow of thoughts. If you say that this information follows from this information, then that really doesn't make any sense. So now we know that these are equal, and then we can just do basic algebra. It follows from this that 3 must be equal to 3x minus 9, because that's just basic algebra, subtraction property of equality. And then it follows from this that 12 is equal to 3x, because we just added 9 to both sides. And it follows from this that that 4 must be equal to x, because we use the division property of equality. And then obviously we have our final statement. And again, notice that the reasons are written below. Why is AB congruent to CD? Because that's given. Why are the lengths equal? Because that's just the definition of congruent segments. Why did we come up with this equation here? Well, because we plugged in this information here and this information here using the substitution property of equality, and that's why we wrote substitution property of equality under the bubble. This is the reason. Again, that's the green is the reason, and the blue in the bubble is the statement. All right, so I want you to try one of those. And again, don't be nervous about this, because in this first problem here, I'm giving you the proof in two-column form. You don't actually have to do the proof. You probably could if you went back and reviewed the proofs that we did earlier in the course. But you can see it right here. So all I want you to do is convert this to a flowchart form. And you can take a screenshot of this example if you need to use in problem number 8. So go ahead and try number 8. And again, just use common sense. Every step needs to flow from another step, except the given information, of course, and a few other things. So go ahead and try number 8, and when you come back, we'll do it together. All right, we're back. So your flow chart should look something like this. Obviously, if the angles are congruent, then the measure of the angles must be equal. So this information follows from this information. That's why we have arrows connecting them, or one arrow connecting them. And this information over here, again, this was just given in the diagram. So this doesn't follow from anything. So we have to have a separate branch over here. But when we use substitution property of equality, we're using both this information and this information. So we have two arrows connecting to this bubble. So this proof is almost exactly the same as the previous proof we did, except now we're using angles. And then of course you just follow the logic here, the steps of the equation, and each one of these steps follows from the previous step, because again it's just a basic algebraic equation. And so why don't you go ahead and pause the video and look at that, analyze that for a little bit, and when you're done, start the video and we'll go on to number 9. All right, we're back. So for number 9, we have the same thing here. I'm giving you a 2-column proof, and you can go back and review this if you need to. Let's just go over the basic idea. We haven't done this in a while. We're told that the measure of angle ABC is 130 degrees. So this angle is 130. We want to prove that the measure of angle CBD, this angle, is 50. So we start off by saying that this angle and this angle form a linear pair. Now why is that? Well, we can see it just by looking at it. They share the same vertex, and the non-common rays, or the non-common sides, are going in opposite directions. So that means that this angle and this angle form a linear pair. And why do we know that? Well, we can just see it in the diagram. And by the linear pair postulate, remember that linear pair postulate, if two angles form a linear pair, then they must be supplementary. Now, why do we care about that? Well, because if angles are supplementary, by definition, that means they add up to 180 degrees. And we know this information, that's given. So then we can just plug in 130 to ABC here using the substitution property of equality, and just subtract 130 from both sides, and we get the measure of angle CBD is 50 degrees. So you can see there's a flow of thoughts here, but it's hard to show that flow when you can only go straight down in columns. So now you're going to convert to a flowchart form. So go ahead and try that, and when you come back, we'll do it together. All right, we're back. So your flowchart should look something like this. Now, I need to stress, it doesn't have to look exactly the same. Your flow of ideas may go from left to right. They might float down from here to here. That's okay. There's a lot of different ways to do this. In fact, there's probably an infinite number of ways to do this. But the flow of thought should have this basic form. So angle ABC and angle CBD form a linear pair. That's just basically given information in the diagram. But it follows from the diagram. It follows from that information, because they're a linear pair, they must be supplementary angles. Okay, so this follows from the fact that they're a linear pair. And we use the linear pair theorem. Actually, I'm sorry, that should be linear pair postulate. Some courses call it a theorem, some courses call it a postulate, but I'm just going to call it a postulate, even though it probably should be a theorem. So it follows from that, because the linear pair postulate, we know that they're supplementary, and then from that we know that the angles must add up to 180, because that's what supplementary means. So it follows from this that the sum of the angles must be 180. And why is that? Because the definition of supplementary angles. So then we use this information and the fact that one of the angles is 130 to plug in 130 to that equation. Now, again, this is information that doesn't really follow from anything. We're just given the information, so that's why we start with a different branch here. But we need this information and this information to show why this is true with the substitution property of equality. So that's why these two are joining together to make the bubble here. And it follows from this, if we subtract 130 from both sides, it follows from this that the measure of angle CBD must be equal to 50 degrees. So again, your flowchart proof doesn't have to be exactly the same, but that's the basic idea. So if you got that answer or something similar to that, good job. You can pause the video and analyze that for a little bit if you need to. It's probably good that you do that, and when you're done, start the video and we'll go on to number 10. All right, we're back. So on to number 10. So you're going to prove the vertical angles theorem, that the idea that vertical angles are congruent. So you want to prove that this angle and this angle are congruent. They're vertical angles. Remember, they're also called opposite angles. And we have the two-column proof here. So we start off with the basic information that angle 1 and angle 3 are vertical angles. We can see that in the diagram. And angle 2 and angle 1 form a linear pair. Now we talked about that in the previous proof. Because these rays are going in opposite directions and the two angles, this angle and this angle, share a common vertex, it's a linear pair. But angle 2 and angle 3 are also a linear pair. They share a vertex and their rays are going in, their non-common rays are going in opposite directions. So because of that information, we know that those pairs are supplementary because they form because 1 and 2 form a linear pair, they must be supplementary, and because 2 and 3 form a linear pair, they must be supplementary also. Now there's a theorem that we learned called the congruent supplements theorem that says if two angles are both supplementary to the same angle, then those two angles must be congruent. So angle 1 must be congruent to angle 3 by the congruent supplements theorem. So that's just a basic review of that proof. And I want you to try to convert that to flowchart form. Now be aware that placing this statement here is going to be a little weird. It's not exactly obvious why we even need this information at all, but just place that somewhere. And when you come back, we'll do it together. All right, we're back. So here's an example of a flowchart. Again, this information is kind of hard to place it, but we can just say that they're vertical angles, and I guess technically it follows from that angle 2 and angle 1 form a linear pair, and angle 2 and angle 3 form a linear pair. And it follows from that those angle pairs must be supplementary, because that's the linear pair postulate. And if they're supplementary, then we can use the congruent supplements theorem to say that angle 1 is congruent to angle 3. So again, your flow chart should look something like that. It's not going to look exactly the same, but the flow of thought should be roughly the same. So go ahead and pause the video and analyze that. And when you're done, start the video and we'll go on to problem 11. All right, on to number 11. So again, I give you the 2-column proof. This proof is fairly standard. We're told that BE is perpendicular to DE. So this line is perpendicular to this line. That's what that symbol means. Remember, perpendicular. So we're also told that ABC is a right angle, and that's what that square is down there. Probably can write that a little bigger. And we need to prove that angle ABC is congruent to angle DEB. So we need to prove that this angle is congruent to this angle. So we know that those lines are perpendicular. That's the given information. And because they're perpendicular, by definition, this angle must be a right angle. That's what perpendicular means. If this line is perpendicular to this line, then angle DEB must be a right angle. In fact, this must be a right angle also, and this angle and this angle. But we only care about DEB in this proof. Now, if this angle is a right angle, and we also know that this angle is a right angle, then they must be congruent by the right angle congruence theorem. Remember, there's that theorem that is so obvious, it's hard to believe that mathematicians actually stated, but if two angles are both right angles, they must be congruent. That's the right angle congruence theorem. So now try to convert that 2-column form into flowchart form, and when you come back, we'll do it together. All right, we're back. So they're perpendicular, the lines are perpendicular, and it follows from that angle DEB must be a right angle, because that's the definition of perpendicular. And we also know that angle ABC is a right angle. That was given, but that doesn't follow from anything. That was just given. But we need to use both these pieces of information to conclude that angle ABC is congruent to angle DEB using the right angle congruence theorem. So again, the spacing of your bubbles may not be exactly the same spacing, but the flow of thoughts should be approximately the same for your proof. So you can pause the video and analyze that a little bit if you need to. And when you're done, start the video and we'll go on to problem number 12. All right, on to number 12. So we have another 2-column proof here. And this proof looks like it's going to be difficult, but it's really not. As you can see, it's only 4 steps. If B and C lie between A and D, in other words, if they're collinear, in geometry, if it says a point lies between, that means that it just assumes that they're collinear. You might say that this point lies between these other 2 points, but in geometry that's not really what that means. In geometry, if you hear lie between, that means it has to be collinear. It doesn't have to be the midpoint. It just has to be somewhere on the line connecting those 2 points. So if B and C lie between A and D on the segment below, then AD, the whole length, must be equal to AB plus BC plus CD. So the concept is very simple, but actually proving it takes a little bit of thought. So B and C lie between A and D, that's given information. we know that AD, this whole length, is equal to AC plus CD. That's step 2. That's the segment addition postulate. But we also know that AC, just taking AC by itself, AC must be equal to AB plus BC. That's step 3. Then we can take that blue part, this blue part here, and we can substitute that in for AC. So we're using both of these equations to go to step 4. And you notice that I put an arrow there. We have such a need for a flowchart proof that I'm actually writing arrows on the 2-column proof. So you can see that flowchart form is really useful. So go ahead and try to convert that proof to flowchart form. And when you come back, we'll do it together. All right, we're back. So because B and C lie between A and D, the segment addition postulate must apply because, again, that means they're collinear. And this segment addition postulate also follows because we can see by the diagram that B is between A and C. And using both of these pieces of information, we can combine them to say that the sum of those individual segments is equal to the length of the overall segment by the substitution property of equality. So if your flowchart looks something like that, good job. You can pause the video and analyze that if you need to. And when you're done, start the video and we'll go on to number 13. All right, we're back. So now here's a somewhat longer proof. It's long, but it's not really that difficult. So if ABC is equal, the measure of ABC is equal to the measure of ADC below, and if the measure of EDF is equal to the measure of EGF, then segment EG must be perpendicular to segment GF. So we have to show that this angle is a right angle, and somehow we're going to use this information. We see that that's a right angle, and keep in mind that it doesn't say that in the actual if-then statement up here. You have to look in the diagram to see that this is a right angle. That's very important. And we're told that ABC is equal to ADC, so this one's congruent to this one, so on and so forth. And you can just follow the steps there. So go ahead and look at that, see if you can understand it. We're really just using the transitive property of equality over and over again. And you have to show that, again, you have to show that this angle EGF is 90 degrees or a right angle, because if you can show that that's a right angle, that proves that segment EG is perpendicular to segment GF. So go ahead and try to convert that to flowchart form, and when you come back, we'll do it together. All right, we're back. So your flowchart should look something like this. If ABC is a right angle, and then again we see that in the diagram, then it follows from that the measure of the angle must be 90 degrees by the definition of right angles. If we know the measure of ABC is equal to the measure of ADC, that's given information, then we can use both these pieces of information, combine them, and using the transitive property of equality to say that the measure of ADC must be 90 degrees. So the measure of this angle must be 90 degrees. But we know that this angle is congruent to this angle because you see we have two line segments that are crossing each other, which means that there are vertical angles. All the vertical angles must be congruent. This angle must be congruent to this angle. Those are two vertical angles. And there's this angle and this angle, which we don't really care about, but they must be congruent also. But that's what this information tells us. By the vertical angles theorem, we know that the measure of ADC is equal to the measure of EDF. But we just proved that the measure of ADC is 90 degrees. So if this angle is 90 degrees, that means this angle must be 90 degrees also. So that's what this information tells us. So we combine this information with this information to get this information. And so now that we know that EDF is 90 degrees, we can combine that with this information, which was given in the first statement, to show that measure of EGF is 90 degrees. We're told that this angle is congruent to this angle. That's the given information here. So if we know that this angle EDF is 90 degrees, then by the transitive property of equality, this angle must be 90 degrees also. So EGF is 90 degrees, and if it's 90 degrees, by definition, that means it's a right angle. And if it's a right angle, that means that EG is perpendicular to GF. By the definition of perpendicular, that's what it means to be perpendicular. So you can pause the video and analyze that more if you need to. And when you're done, start the video and we'll go on to problem number 14. All right, we're back. Okay, so now you're going to try some flowchart proofs, but I'm not going to give you the two-column form. So you're going to have to actually do this proof and write the flowchart form on your own. So we're going to start with an easy one, a fairly easy one, number 14. So you're going to need the vertical angles theorem. That's the theorem that says that this angle is congruent to this angle because they're across from each other. They're vertical angles. So again, it's called the vertical angle theorem. So go ahead and try number 14. Do your best, and when you come back, we'll do it together. All right, we're back. So your proof should look something like this. It's pretty standard, as you can see. This is given information. We also know that measure of angle 3 is equal to the measure of angle 2 by the vertical angles theorem, and this does not follow from this. So we're not connecting them really. But we are going to use these two pieces of information to conclude that the measure of angle 1 is equal to the measure of angle 3 by the transitive property of equality. So we draw arrows down to this bubble here. So stop the video and analyze that if you need to. And when you come back, we'll go on to the next problem. All right, so on to number 15. Number 15 says we're going to write a flowchart proof for the converse of number 7. So let's look at number 7. I wrote number 7 up here, so we didn't have to go back to it. So this is the original statement, but we need to prove the converse of that. So that means that we're going to start with x equals 4. You see, we're going backwards, and we're going to prove that these two segments are congruent, that AB is congruent to CD. So this is going to be a much longer proof than number 14. Obviously, there was only 3 bubbles here. It was pretty easy. But this one's going to have quite a few more bubbles than number 14. So go ahead and try number 15. And again, you're starting with x equals 4, and you have to prove that AB is congruent to CD. So try 15, and when you come back, we'll do it together. All right, we're back. Your proof should look something like this. We know x is equal to 4. That's given information. Again, it's the converse of this statement, so we're starting with x equals 4. And we also know that by the diagram that AB and CD are equal to those expressions there, and we can combine that using substitution to plug in 4 to each one of those expressions and simplify to get 11 for both of them. And obviously, if they're both equal to 11, then the lengths are equal to each other. And by definition, AB must be congruent to CD. So that was a fairly simple proof. That's about double the number of bubbles of this proof over here, but it's still fairly simple. So if you got that answer, good job. If you need to analyze that, or you probably should analyze that a little bit, so stop the video and look at that in more detail, and when you're done, start the video and we'll go on to number 16. All right, so on to number 16. Number 16 and number 17 are going to be quite a bit more complex as far as the flow of thoughts. So just be aware of that. These are going to be challenge problems, I guess. But it's using all the principles that we used in the previous problems. So this really shouldn't be that difficult. It's just that the flow of thoughts is going to be a little bit more complicated. So go ahead and try number 16. And you're going to have to use the segment addition postulate. Be aware of that. And when you come back, we'll do it together. All right, we're back. So your proof should look something like this. It doesn't have to look exactly the same. You know, don't panic if your proof isn't exactly the same as mine. It could still be correct. The general idea is we want to start with the given information, obviously. And these expressions are part of the given information, but we know these from the diagram. And so if B bisects AC, then by the definition of a segment bisector, we know that AB is equal to BC. So this length is equal to this length. And we can use these expressions and this information here to conclude that x plus 2 must be equal to 2x minus 1. And then we can just do all the algebra and find that x equals 3. And we also know by the segment addition postulate, sorry, I'm just waiting for my computer to speed up. We know by the segment addition postulate, which is kind of a separate information there, that the total length AC is equal to AB plus BC. And we can just plug in these expressions here using this information. So combining all that, we get this bubble here. And then we can just simplify to 3x plus 1. And now at that point, we are going to combine this information and this information. So that's why we have arrows connecting this bubble here. And then we just simplify and we have AC is equal to 10. So again, that might seem a little complicated, but it's really not. It's just a basic flow of thoughts. So stop the video and analyze that in more detail if you need to. And when you're done, push play and we'll go on to problem number 17, the last problem for this video. All right, we're back. So number 17, if the measure of angle DBC, if the measure of this angle is equal to 70 degrees, then ray BD bisects angle ABC. So that ray bisects this angle. And if it bisects, remember what that means is that it goes right through the middle so that the measure of this angle is equal to the measure of this angle. So that's what you're going to prove. So this may be a little different from the proofs that we did previously, I believe. I don't remember if we did one exactly like this today, but go ahead and try number 17. And what you're really doing is you want to prove that the measure of this angle is equal to the measure of that angle. If you can somehow do that with the given information, then you're pretty much done, because that proves that BD bisects angle ABC. So try number 17, and when you come back, we'll do it together. All right, we're back. So your proof should look something like this. And obviously we're starting out with the given information, which includes the measure of angle DBC, but also we know the measure of angle DBC is equal to that expression, 5x plus 55. So we're going to combine that information with these two arrows to get an equation. And obviously with that equation, we can find x is equal to 3. And once we know that x is equal to 3, we can then take this expression up here that says that the measure of angle ABD is 20x plus 10. And also using this information, we can come together on this bubble here and just plug in x to those expressions. So then we just simplify these expressions and we end up with the measure of angle DBC is equal to 70 degrees and the measure of angle ABD is also equal to 70 degrees. So we're almost there. And we can use a transitive property to say that those angles, or the measures of those angles, are obviously equal. And by the definition of congruent angles, well, actually, no, we don't have to go to that. We just say because the measures of those angles, because this angle is 70 degrees and this angle is 70 degrees, because they're equal to each other, we can say that BD bisects angle ABC, this overall angle here, and we know that because it's the definition of angle bisector. So you can stop the video and analyze that further, and when you come back, we'll take screenshots of the work we did today. All right, we're back. So let's take screenshots of the work we did. If you want to use these for your to study for tests or to do your homework. So here's screenshot number 1 and screenshot number 2 and screenshot number 3 and screenshot number 4 and screenshot number 5 and screenshot number 6 and screenshot number 7 and number 8 and number 9, number 10, and number 11, and number 12. All right, let's take a look at the homework. So here is screenshot number 1. So we have four problems for the homework. That's it. So I want you to write a paragraph proof and a flowchart proof for this problem. And I want you to write a paragraph proof and a flowchart proof for this problem. And for 3 and 4 also. So only 4 problems, but you're going to be writing technically 8 proofs because you need to write both forms for each of these proofs, the paragraph form and the flowchart form. So that's screenshot number 1. And let's look at the answers. Here's screenshot number 2. And screenshot number 3. And screenshot number 4. Remember, your flowcharts and your paragraph proofs don't have to be exactly the same as mine. This just gives you a guideline for what you should be looking for. So do that homework completely correctly, neatly, and put it in order in your binder. And we may be at the end of the course. I may do 1 or 2 other classes, but we're pretty much at the end of the course. So we're going to take test number 5 or 6, I can't remember which one it is, and then we're going to take the final, and you're going to be done with this course. So good job, and I'll look forward to seeing you in the next class.